Yes, very good afternoon to all. Today I will be discussing that physical chemistry 2. In this part, I will be discussing about the first block, that is theories of chemical kinetics. So, what is chemical kinetics? Chemical kinetics ಅಂದ್ರೆ ಏನು? It is the study with respect to reaction rate, effect of various variables and rearrangement of atoms, formation of intermediates. So basically, what does the chemical kinetics andre? It is the study of rate of chemical reaction. So one reaction is taking place andre, we are going to study with respect to rate, at what rate the reaction is taking place, and also with respect to various variables means atoms and also rearrangement of atoms and formation of some of the reaction. There will be formation of intermediates. Product form ಆಗಕ್ಕೂ ಮುಂಚೆ intermediates form ಆಗುತ್ತೆ. That we are going to study in this chemical kinetics. So previously in the first semester also we have discussed about chemical kinetics. There we had studied about ಯಾರು ಸ್ಟಡಿ ಮಾಡಿದೀವಿ the fundamentals of chemical kinetics. So what are the fundamentals? What we are studied in the previous semester? And the molecularity, rate of reaction, the factors influencing the rate of reaction, and order of reactions. We have discussed zero order, first order, and second order reactions we have discussed, and also with respect to half-life period. This we have discussed in the previous semester. Also, such as you know the order of reaction with respect to reactant and total order of the reaction, uh, parallel reaction, reversible reactions. So what are the reaction rate taking place? And we have studied about the molecularity of the reactions. And we have previously discussed about multi-component reaction, reversible reaction, and with respect to different rate theories. First semesterly that we had discussed fundamentals of chemical kinetics. So that is the continuation in this block, first block in the physical chemistry. Here we are going to study with respect to theories of chemical kinetics, that is collision theory, activation of complex theory, alignment theory for unimolecular and bimolecular reaction, and also factors affecting the order of reactions. This will be in the block 1 of physical chemistry. So that is theories of chemical kinetics. So in this unit 1 of block 1, that is collision theory. What does the collision theory says here? Collision theory andre ಏನು? So collision theory, the theory used to predict the rate of chemical reaction. So mainly for gases. So here also we are going to study with respect to rate of reaction mainly for the gases. So that is with respect to collision theory. In this unit we are going to discuss about rate expression for rate equation for collision theory and a rate expression for rate equation for unimolecular, Lindmer's theory, limitation collision theory, and the rate expression for activated complex theory, and few problems are there in this unit. So again, what is chemical kinetics? Chemical kinetics is nothing but reaction kinetics or rate of chemical reactions. So at what rate the reaction is taking place, That is known as chemical kinetics that we are going to study here. So with respect to different reactions, we are going to take some simple examples and the time taken for completion of that reaction we are going to study in this unit. So collision theory is the theory used to predict the rate of chemical reaction mainly for the gases. So the rate at which the reaction occurs very considerably for reaction. So that is known as chemical kinetics. For example, here we are taken uranium 238 to pyrogen. How much years it is needed to complete half of that reaction, Andre? It is more than 5 into 10 to the power of 9 years for the completion of that reaction. So for different molecules, we'll take different time for the completion of the reaction. Also one more, sulfate plus hydrogen gives hydrogen sulfate, which takes 3 into 10 to the power of minus 4 seconds. Within a fraction of seconds, the reaction will be completed. So depending on the chemicals or molecules which we are taken for the reaction, so the rate will varies. Means the time taken for completion of the reaction. So here reaction kinetics deals with the factors which influences the reaction velocity. So, for example, if you take corrosion, where iron in the presence of air or water forms to corrode, so it will take few months. So, depending on the rate of rusting, depends strongly on composition of iron. So, it will be composition of iron and steel composition with different percentage of composition. So it less rapidly it varies. Means mainly with respect to different composition. ಈಗ iron composition steel percentage ಜಾಸ್ತಿ ಇದ್ರೆ the corrosion will be very slow, and pure stainless steel the corrosion will not be taking place. So depending on the composition of those material also the reaction depends. And coming to the next topic is theory of reaction kinetics. So here it is nothing but the chemical kinetics. Here this plot explains the what it explains. To explain the molecules acquire the energy of activation. Two theories have been provided. So it is number of moles with respect to energy as the this is the activated area. The conversion of A to B means A is then reactant, the B is the product form. So conversion of A to B, there will be a formation of energy liberated. So that is known as energy of activation or theory of reaction kinetics. Here we'll be having two different theories we'll be discussing in this theory of reaction kinetics, that is collision theory of reaction rate and activation complex theory of reaction rate. So in the collision theory it explains how chemical reaction occurs and why reaction rate different from different reaction. So different it explains how chemical reaction occurs and why reaction rate different from different reactions. Why it varies from different reactions are depending on the chemicals what we are taken for the reaction to complete. So the reaction rate will vary, and the theory states for the reaction to occur on reactant particles must collide and That generally two reaction particles will be taken, considering this one reaction particle and this one another reaction particle A and B. So when it gets collided, the reaction take place. So the reaction particle must collide and certain friction should be taking place for the total collision. And small molecules of molecules have enough energy and with respect to right orientations. So here the reaction molecule must approach each other so closely for the reaction to occur. So when these two molecules approaches very close, so that reaction can be taken place. And A is one molecule A and another one is the molecule B. So here sigma AB is not, uh, it's an collision diameter. What we are given here, the sigma AB, that is the collision diameter between the two molecules. So if sigma AB is not greater than DAB, the collision will occur. Chemical reaction will take place. The diameter of AB. Diameter means this is the diameter of A molecule andre this is the total diameter of A and this is the diameter of B. It should not be greater than DAB. So if both were collided, the sigma AB should not be greater. Means if there is a greater than AB, ಈ AB ದು molecule A and molecule B ದು diameter ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ it won't get collided. So sigma AB should be less than the diameter of two molecules. This diameter should be less than of this individual A molecule and B molecule. During collision, the rearrangement of bonds will take place and also there will be a redistribution of energy taking place. So, how you are going to calculate the molecular diameter? Molecular diameter, how you are going to calculate andre DAB is equal to dA plus dB by 2. So sigma AB is the collision diameter. This is represented as collision diameter. So only these activated molecules can take part in the reaction, such as Arrhenius equation. Arrhenius equation, what is it says here? Arrhenius equation only. Acid dissociates to give H plus ion and base dissociates to give OH minus ions in water. So if A is the frequency, how you are going to calculate the Arrhenius theory? You are going to implement in this rate. So K is equal to A into minus E by RT. So K is the rate constant. A is the Arrhenius constant. This A is represented as Arrhenius constant. EA is the energy activation. EA represents the energy of activation. R is the gas constant and T is with respect to temperature. So these all the conditions will be measured while the reaction is taking place. So previously in thermodynamics, we had studied by keeping when the reaction is taking place inside the box, we are keeping temperature, pressure constant, or by varying temperature, we are going to measure the completion of that reaction. By varying pressure, we have studied, we have derived the equations. So you are in this for calculation of rate constant with respect to Arrhenius theory. Here we are going to keep measure the what energy of activation R, that is the gas constant, and temperature we are going to measure to calculate the rate constant. So Further, Arrhenius theory equation 1 can be written as log taking log of k is equal to log of a minus e by 2.303 into RT. So plotting the graph from this graph, what you are going to find log k is equal to 1 by t. So here we are going to calculate the slope. That is slope is equal to minus e by 2.303. That is E is nothing but energy of activation. So that we are going to calculate by keeping rate constant and temperature. So in the next, the collision theory for bimolecular reaction. In the previous topic, we are discussed with unimolecular reaction. So here we are going to take two different molecules. A plus B gives product or both the A molecules which gives to the product. So here what are the advantage of bimolecular reaction? The molecule should be colliding with each other, and bimolecular andre two molecules, and the activate molecules take part in the reactions. So here we are going to calculate the rate of reaction between bimolecular reaction. So same thing, N is equal to N to E power of minus E by RT. E is the activation energy, R is the gas constant, T is the temperature, where we are going to calculate the zeta, that is the collision number. Here the reaction is between two, if the molecules are identical, means two same molecules are taken, that can be denoted as identical molecules. So A plus A gives the product, that will be A of identical molecules, where hydrogen and iodine gives hydrogen iodide. So that is the example taken for the identical molecules for bimolecular reaction. So that is the zeta is the collision number, and number of collision taking place, number of collision between the molecules on gas. So it is basically what we are going to study in this Chandra collision theory. It is mainly the rate of chemical reaction for gas variables. So that's why you are taken here example hydrogen plus iodine, which form hydrogen iodide. So in this collision theory, mainly the components taken for the reactions are in the gaseous state, and it can be measured in the cubic centimeter, number of molecules in 1 cubic centimeter of gases. N is the number of molecules in 1 cubic centimeter of gas. C is the average velocity of molecules, which is equal to root of 8 kt by m, that it can be denoted as C. And zeta IA is nothing but the collision numbers, number of collision taking place. So that is with respect to equation 7, that is for two identical molecules. So it can be for two different molecules K, that can be denoted as A plus B gives the product. Same thing, number of collision for zeta AB, that is NB, that is the number of molecules in A and number of molecules in B reactant. So A plus B, A B ಅಂತ ಇದೆಯಲ್ಲ. So this can be denoted as A plus B, where forms the product. This is the number of molecules in the A, and NB is nothing but number of molecules in the B reactant. So next, with respect to rate constant ಹೆಂಗ್ calculate ಮಾಡ್ತೀರಾ? K is equal to rate by n square, rate of two identical molecules ಗೆ, that will be A into A for equation 5 and 7. The equation 7, and previously from the equation 5, that is V is equal to ZE by minus ER, E by RT. So it can be denoted as the K is equal to 2 n sigma square into pi kt by m of alpha e to minus e to the power of e by rt. So that is the equation 11. N is the Avogadro number. So similarly for the A plus B gives the product by rate by NA, that is nothing but the number of molecules in A reactant, and NB is the number of molecules in the B reactant. Same thing, same equation they have derived for the two different molecules here. A, B, two different molecules ತಗೊಂಡಾಗ they have calculated. Next K is equal to n sigma square into AB, where here 1, ಇದು comparing 1 and 11 ಅಂದ್ರೆ 1 is nothing but rate constant of the reaction. Equation 1 is, what is the equation 1? That is the rate constant of the reaction, that is K is equal to A into e power minus EA by RT, that is the rate constant of the reaction. And what does the equation 11 says here? The equation 11 now, that is for two identical molecules. ಎರಡು ಸೇಮ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ತಗೊಳೋದಾಗ ರಿಯಾಕ್ಷನ್ಗೆ, this is the expression derived, that is equation 11. K is equal to 2n sigma square into pi kt by m power of 1 by 2 into e to the power of minus e by rt. That is the equation 11 for two identical molecules. So for two different molecules, we have got the equation 13. That is A plus B gives the product. For two different molecules, we have derived the equation 13. So here mainly what we have studied until here, Andre, the main thing is bimolecular reaction for identical molecules, and two different molecules we have derived the equation, means rate constant for those reaction. So next is the test for collision theory. Here the comparison means test for collision theory, we have taken an example for hydrogen iodide, forming hydrogen and iodine. So K experimental andre, K theoretical andre, what is it says? Iverdo K, that is the rate constant. Experimentally we have got 3.5 into 10 to the power of minus 7 liter per mole second, and theoretically what we have calculated by using this formula, theoretically we have got 5.2 into 10 to the power of minus 7 liters per mole inverse second inverse by second or by mole. So here we have taken simple reactions such as alkyl iodide and tertiary amine gives quaternary ammonium complex. One example they are taken, and For this, the collision between the activated molecules will not be happen because it occurs critical orientation of molecules during the collision theory. So the orientation of those molecules also it matters, and it can be denoted by P. So why you are denoting probability means it may occur or not. The probability factors are steric factors. It can be denoted. So if P is greater than 1, the chain reaction is taking place. If P is less than 1, the viscous reaction, which is K experimental is less than K theoretical. So the probability what we have discussed ಇಲ್ಲಿ ಎರಡು ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ ಅಲ್ಲ ಒಂದು ರಿಯಾಕ್ಷನ್ಗೆ we have got two different values. For example, hydrogen iodide forming hydrogen plus iodine. So that is with respect to K experimental and K theoretical. The values are little it varies ಅಲ್ಲ. So theoretical ಮತ್ತೆ experimental calculation ಮಾಡಿದಾಗ the rate of reaction is varied. So for that probability to identify that how much the difference it may, we are studying with respect to probability. So whether probability means nothing but less or more, either this or that ಅಂದಂಗೆ probability means. So if P is greater than 1 ಏನಾಗುತ್ತೆ, if P is greater than 1 ಅಂದ್ರೆ rate of reaction experimental is greater than theoretical value. The probability what this value ಇದನ್ನ ಹಿಂಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ ಈಗ ಕೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ 3.5 ಇದೆ, ಕೆ ಥಿಯರಿಟಿಕಲ್ ದಟ್ ಈಸ್ 5.2 ಇದೆ. ಕೆ ಥಿಯರಿಟಿಕಲ್ ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ ಕೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಅಲ್ಲ. ಸೊ ದಟ್ if k theoretical is greater than k experimental ಅಂದಾಗ what is that says k theoretical is greater ಅಂದ್ರೆ p is the probability is less than 1. So for this equation ಗೆನೆ how you are going to probability of this ಅಂದ್ರೆ identify ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ, so here the equation key rate of reaction theoretical 5.2 is greater than rate of reaction experimental 3.5 less ಅಲ್ಲ. So k theoretical is greater than k experimental. K theoretical is greater than k experimental ಅಂದಾಗ the probability p is less than 1. So if k experimental is greater than k theoretical, p is greater than 1, the probability is more than 1. So here one more the consequence will take place where AB will not directly gives to product. It may give AB will not directly forms the product. There will be formation of some intermediates there will be formation, then in the next step the formation of the product will be taking place. So this will be one more criteria, and the reaction taking place in the given diagram uh, of hydrogen and iodine. So molecular bonds each other if there is no reaction taking place. And this is with respect to probability factors, whether theoretical is greater than experimental or experimental is greater than theoretical. It can be explained in the probability factors or steering factors. So the collision which occurs, critical orientation of molecules during the collision is necessary. So orientation of these uh, reactants, what we have taken, that is also is necessary for the reaction of taking place. And next, is the limitations of collision theory. So, what are the limitations it is having? Collision theory. So, it do not depend on the shape of the molecules. Mainly, uh, theory states that the shape of the molecules which does not depend. So, it treats the molecules of the reaction whether it is in hard, rigid shapes, which is not always true. So it mainly does not depends on the shape of the molecules, whether it is rigid or flexible, it doesn't matter. So the theory assumes the collisions in all directions are equal, favorable, which is not true. So in the theory assumes the collision in the all the directions will be taking place. So it is not true. Means it should collide collide ಆದಾಗಲೇ the reaction will be taking place. So that is with respect to collision. And next is the attempt to explain the value of P is not completely successful. So P is nothing but the probability factor or steric factor. So the probability means whether the experimental is greater than theoretical or theoretical is greater than experimental of rate of reaction. The rate of reaction varies with respect to theoretical and experimental that can be denoted by P, that is the probability factor. Also, in some cases, the experimental value will be abnormally high, which is not possible to explain in this theory. So, some of the reactions, the probability factors are experimental value or abnormally high. Andre, this experimental value is nothing but the rate of reaction, which may be high, which is possible, which is not be possible to explain in this theory. And one more, one of the main and they failed to explain the reversible reaction. So this one is very important. See, the main theory limitations andre. So A plus B gives the product, it can be explained, but for the reversible reaction, it cannot be explained in this collision theory. So that is also a main drawback of this collision theory. And coming to next that we are going to explain in the reversible reaction. So how the equation can be derived for the reversible reaction, we are going to study the rate of reaction. So A plus B gives the product that AB and further it can be reversed. So giving the product A plus B. So K1 is for forward reaction and K2 is the rate of reaction for backward reaction. So for forward reaction K1 is equal to P1 Z1 E to the power of minus E1 by RT. So that is with respect to equation 1 ಏನು ಹೇಳ್ತದೆ ಏನು ಹೇಳುತ್ತೆ so so K1 is the rate constant for forward reaction and K2 K minus 1 they are given or K2 it can be represented, that is the equation to for rate of reaction for backward reaction. So that is the rate constant reaction. It's a general equation. So for calculating delta G minus RT ln of K, RK is equal to e to the power of minus delta G by RT. So here it can be written in the form of equation 4. Also it can be written K is equal to e to the power of minus delta G by minus RT into e to the power of delta S by RT. That is the equation 5. So taking this K for general rate reaction to determine that K1 rate reaction of forward divided by K2 for backward reaction. If you divide, you will get the general rate of that reaction. So that can be the here the equation how you are going to K is equal to K1 by K minus 1. K minus 1 also it can be denoted as K2, that is for backward reaction. So next we are going to insert the values of rate of reaction for forward and backward reaction in this equation, and further it can be resolved since we will get the equation 6. So molecules A, B and AB are comparable in size. Z1 is equal to beta 1 is equal to beta minus 1. So the molecules are comparable size will be equivalent. So it is not sufficient to correlate the probability factors with the structure orientation of the molecule during the collision. So what are the drawbacks of this? The probability factors cannot be determined only with respect to orientation of those molecules or size of those molecules. The probability factors cannot be discussed. So this is with respect to unit 1. Unit 1 ನಲ್ಲಿ we have discussed the collision theory for bimolecular reaction. With respect to identical molecules are two different molecules. Also reversible reaction with respect to two different molecules. So next from here, that is Lindman's theory for unimolecular reaction. That is collision theory for unimolecular reaction. Lindman theory ಸ್ವಲ್ಪ ಜಂಬಲ್ ಆಗಿದೆ. This 1.7 7.7 that comes Lindman theory for unimolecular reaction, that is with respect to unit 3. Unit 3 ಇದು ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ Lindman theory for unimolecular reaction. So here the collision theory explains the mechanism mainly for bimolecular reactions. In unimolecular reaction, only one molecule take part for the reaction. So unimolecular andre one molecule. Bimolecular there will be two molecules will be taking for the reaction. And according to Lindman theory, what does the Lindman theory says here andre? The activation of molecules take place through bimolecular collision among themselves. So the activation of molecules plays through bimolecular collision among themselves. If the reaction vessel contains n moles of A molecule, then molecules are continuously colliding with each other. So the reaction vessels containing n molecules of A molecule, then the molecules are continuously colliding with each other. Then the rate is not proportional, means the molecules get activated from, and there will be time lag between the activation and reaction during the time. So then the rate is not proportional to the concentration of all molecules activated. So Lindman hypothesis can be represented as follows. So this is the hypothesis of Lindman theory. So colliding with other molecules, it's nothing but colliding with other molecules. A plus A with K1 is the rate constant gives the product A plus A star. So for example, here we are taken bimolecular reaction. ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಏನ್ ತಗೊಂಡಿದ್ದೀವಿ CH3 of 2 into N2 gives ethane plus nitrogen. That is the first order reaction. So that we have taken acetamide forming ethane plus nitrogen. That will be of first order reaction. So first order bimolecular or unimolecular. That is andre this is of unimolecular. So that can be formed. How the rate of reaction can be calculated andre A plus A gives the product A plus A star, and in the next step, it gives the product A plus A, and further A star will be converted into a product B. So this is with respect to rate of reaction, and in the first step, it can be converted into actinide and divided. So the question uh, here, the collision theory mainly explains the mechanism of bimolecular reactions. So, colliding with each other molecules, the element hypothesis can be represented. Here, the A and A star represent the normal and activated molecules, means normal molecules. A and this are normal molecules, and K1, 2, 3 are the rate constant. This K1, K2, K3 are the rate constant. So, energy of activation of you are going to denote andre d by dt of A star is equal to K1 of A star. That is the rate of activation, or K represent the rate of reaction. So rate of deactivation andre when it is coming reversible. So minus d by dt of A star into is equal to K2 of A star into A. That is the equation 2. So the rate of reaction can be denoted as d by dt. So in the third step, A star will be converted into the product BLA. So that is K3. That can be d by dt of equal to K3 of A star. So that is with respect to rate of reaction. And the next is the steady state concept. So what does the steady state concept says here, Andre? Initially there will be no activated molecules. But as the concentration of A star increases, they A star molecule get removed by deactivation and reaction. After some time, a stage will be reached at which the rate of activation is equal to rate of deactivation. So when the activated molecules, the concentration of A star increases, the A star molecule get removed or deactivated and the reaction forms. So the time will be reached where the rate of activation is equal to rate of deactivation. So the plot says for rate of activation we are in the previously we are discussed from the log K by T. As the time increases, the rate of reaction increases. This is the EA, that is the energy of activation. And further, as the this plot will represent here the rate of activation will the with respect to time the rate of deactivation will be taking place. So there will be no activated molecules, but the concentration of A star increases and the A star molecule gets removed by deactivation. So that is the rate of activation with respect to is equal to rate of deactivation. So it can be written as d by dt of A star is equal to 0. Therefore, K1 of A square equal to K2 of A star That is the rate constant in the second step. That is K2 is equal to K2 into A star into A plus K3 into A star. So from this equation, this step can be written. So A star is equal to K3 by K1 into A square by K3 plus K2 into A. That is the equation 4. Since the rate of reaction K3 is equal to A star, wherever that can be written as A star na, it can be written as K3. So from the equation 5, the rate of reaction for unimolecular reaction. Unimolecular andre where the single molecule is converting to form the reaction. So in the case 1, A is larger, number of collisions are high. The rate of deactivation will be high. So that uh, case 1 study A is larger, number of collision are high, and the rate of deactivation will be high. The number of collisions are high andre the rate of activation means activation energy will be high. Now collision now ಈಗ ಪಾರ್ಟಿಕಲ್ ಕೊಲೈಡ್ ಆದ್ರೆ the reaction will be rate of reaction will be increased ಅಲ್ಲ, so the reaction will be high, mean the collision of number of molecules will be high, the rate of deactivation also will be high. After the collision, the formation of the product will be formed, so the deactivation will be also high. K2 is greater than K3, so the rate of reaction is proportional to reactant molecule A, showing the unimolecular reaction will be kinetically of first order reaction. First order reaction, second order reaction ಅಂದ್ರೆ ಏನು? Hmm? Order of reactions. Basically, we are discussed in the previous semester. So, order of reaction, it is very important, plays an important role in the study of reaction kinetics. So, it represents the effect of concentration of variables on the reaction rate. So it mainly the concentration of the variables or concentration of the molecules. So the reaction rate will vary. The concentration of molecules, the concentration of ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ reaction rate, whether it is the concentration is high ಅಂದಾಗ the reaction will be taking place fast ಅಷ್ಟೇ. So this is with respect to order of reaction. So if the rate of reaction depends on first power of the concentration ಅಂದ್ರೆ ಈಗ ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ಫಸ್ಟ್ ಪವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ್ರೆ ದಟ್ ಈಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್. ಸೊ ವೆನ್ ದ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಫಾರ್ ಟೂ ರಿಯಾಕ್ಟೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಈಗ ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ತಗೊಂಡಿದೀವಿ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಟು ಫಾರ್ಮ್ ದ ಪ್ರಾಡಕ್ಟ್, ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ್ರೆ ದಟ್ ಈಸ್ ದ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್. ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಒನ್ ಮಾಲಿಕ್ಯೂಲ್ ಫಸ್ಟ್ ಮಾಲಿಕ್ಯೂಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ್ರೆ ದಟ್ ಈಸ್ ದ first order reaction. Second order reaction andre it mainly depends on the two different reactant concentration andre ಎರಡು concentration ಎರಡು reactant to concentration ಮೇಲೆ depend ಆದರೆ that will be represented as second order reaction. So here they are represented as first order reaction. First order reaction andre it mainly depends on the one concentration of the ರಿಯಾಕ್ಟೆಂಟ್ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಈ ರಿಯಾಕ್ಟೆಂಟ್ ಮೇಲೆ ತಾನೆ, ಹಿಯರ್ ದೇರ್ ಇಸ್ ಓನ್ಲಿ ಒನ್. ಸೊ ದ ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ದಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಪ್ರೂವನ್ ಹಿಯರ್. The rate of reaction is proportional to reactant of A, showing unimolecular reaction will be of first order. So this is the what type of reaction it is? ಇದು ಯಾವುದು ಇದು? Unimolecular first order reaction. So it will be they are given in the step by step. There will be formation of intermediate in the product B ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂತ ಯೂನಿಮಾಲಿಕ್ಯುಲರ್ ಸಿಂಗಲ್ ಮಾಲಿಕ್ಯೂಲ್ ತಾನೇ ಇದು ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಅಂಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಫಸ್ಟ್ ಆರ್ಡರ್ ಅಂದ್ರೆ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಒನ್ ರಿಯಾಕ್ಟೆಂಟ್ ಈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ದ ಪ್ರಾಡಕ್ಟ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್ ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಒನ್ ರಿಯಾಕ್ಟೆಂಟ್. And in the case 2, we are going to study with A is low, means the concentration is low andre number of collisions are very less. The rate of deactivation will be very low. So here mainly the reaction also depends on the concentration of those reactant. Concentration kadme idre activation also will be very less and deactivation will also be very less. So unimolecular reaction shows second order the rate of reaction equal to the rate of activation. So whatever the rate of reaction taking place, that will be activation energy and that will be equal to rate of deactivation. So here plot K versus P. There's a plot K versus P where K is the rate constant, P is the probability factors or steric factors. Probability in there. So the K is independent of P andre at high pressure the reaction is in first order. So it is independent ala. The first order is in independent of P, means it doesn't depends on the rate of reaction. So the reaction is of first order and linearly dependent on P at low pressure, where the reaction is second order that supports Lindemann theory for unimolecular reaction. So it is the second order is linearly dependent on P. So simultaneously with respect to rate of reaction, the second order it also depends on the probability factors simultaneously. So it goes parallel in the second order, linearly dependent on the P, where with respect to first order, it is independent with respect to P at high pressure. So the so this is the unimolecular reaction with respect to second order. And next, activated complex theory. Uh, from here, activated complex theory, it comes under the unit 2. Unit 2 ಅಲ್ಲಿ activated complex theory ಬರುತ್ತೆ. So from here, that is the unit 2 starts, and unit 2, the activated complex theory, the transition state theory or theory of absolute reaction rate. So what is activated complex theory andre the state of particles that is in between the reactant and the product. Is activated complex theory andre it should be knowing the meaning. Activated complex theory andre this is what x ಕೊಟ್ಟಿದಾರಲ್ಲ, so that is the x is the activated complex ಅಂದ್ರೆ the state of particle that is in between the reactant and the product. Reactant go product to madhya irade the activated complex. So that is with respect to unit 2 activated complex theory. So according to this theory, the reactant molecules will combine together forming intermediate and energy rich activated complex. So those intermediates are known as activated complex theory. This X is known as activated complex theory or also known as intermediate. Then the activated complex substantially break up giving the product. Further, it gives the product. So this reaction taking place is known as activated complex theory. And in this unit, the postulates of activated complex theory. What are the sayings here? The activated complex always is in equilibrium with the reactant. So it will be in the equilibrium state. The reaction will be in the equilibrium state. So equilibrium constant how we are going to calculate andre K is equal to C hash by CA to CB. So C is nothing but the concentration of A molecule and concentration of B molecules. Also C hash is the concentration of the product. So depending on the concentration, you can find the equilibrium constant. Equilibrium in constant ಹೆಂಗ್ calculate ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ depending on the concentration of all the molecules and the product. So energy of activation, the activation energy of the reaction is considered as additional energy which the reactant molecules acquires to form the activated complex. So it is an additional energy to form the activated complex. Activated complex under it's nothing but the intermediate. So when the A plus B molecule react to form the product ಬರೋದಕ್ಕೆ ಮುಂಚೆ there will be activated complex means the additional energy when the energy may be liberated while the reaction is taking place. So that energy can be known as in the form of activated complex. So that we are going to study in this plot. So there is two type of reactions. So that is exogenic and endogenic reaction taking place. Exogenic and endogenic andre exogenic andre change in free energy is negative. So if the free energy is in negative state, if the in the positive and additional force is needed. That is known as endogenic reaction. That is delta G is equal to greater than 0. So here the free energy that is delta G is in positive. In exogenic the reaction is in negative. So energy of activation of delta G is equal to with respect to product formation. So the energy is increased ಎಲ್ಲಿದೆ the reactant ಇದು this is the starting point. This is denoted as reactant. Why andre it is the starting part ಅಲ್ಲ. So here reactant this is the product form. So this plot where high intense peak we can see here, so that is the intermediate or activated complex. So where maximum energy is absorbed or generated while the reaction is taking place. That is denoted as EA. That is the energy of activation. So this can be seen. So when the energy of activation is another very less than daga compared to this in the exogenic energy of activation is, so in this black arrow you can see energy of activation, it is very less a lot. So delta G is another less than 0. So delta G, the free energy will be very less when the energy of activation is less andaga. So when the energy of activation is more andre delta G will also be increased. the free energy also will be increased. That is the comparison. You can see it from the plot. EA and delta G. So EA energy of activation is less means delta G also will be in less. So energy of activation is more, the delta G will also increases. Not be equal or same, but the delta G will also be increased. So in the second state, that is endogenic reaction, when the reactant forms the product, the energy of activation is more means the delta G, the free energy will also be more. So the activated complex will have at least one vibrational degree of freedom, and the activated complex vibrates with frequency, it breakups and gives the product. The activated complex vibrates with the frequency, it breaks and gives the product. So one vibrational degree of freedom andre atom more inside the molecule. There will be stretching or bending of the bonds will be formed. So one vibrational degree of freedom andre the atoms more inside the molecules. There will be a stretching or bending of the bonds formation. So vibrational energy E Vib and V is the vibrational frequency. So if the activated complex vibrates with the frequency, it breaks up and gives the product of the reaction. So V can be is equal to Kt by H. So that is with respect to vibrational frequency. So for this, we can use the concept of activated complex theory for the reaction kinetics in two ways, by treating the equilibrium by method of classical thermodynamics and treating the equilibrium by statical thermodynamics and partition function. So there will be two different derivations in this with respect to classical thermodynamics and statical thermodynamics. The same activated complex theory. So ಏನಿಲ್ಲ A plus B gives the with rate of reaction K as gives the intermediate X and further forms the product. So here we are going to calculate the activated complex theory, where concept activated complex theory andre it mainly depends on the concentration of all reactant and the product. So that can be the equation 2 that we has been calculated, and V is the frequency of vibrational and X is the undergo dissociation. X hash undergoes the dissociation. So that can be written as rate of reaction. V is equal to V C hash. C is nothing but the concentration of activated complex. Activated complex andre ಇದ್ರದ್ದು concentration X hash activated complex or intermediate. It can be denoted as X hash. So next we get the equation by resolving. You go through these mathematical terms and by further we get the equation V is equal to RT in H K as Ca concentration of A and B molecule. So since the rate of reaction is KCAB, so again you are going to implement rate of reaction, and next delta G is equal to delta H minus T delta S. This is for Gibbs free energy. Gibbs free energy ಏನು ಹೇಳುತ್ತೆ? G is the Gibbs free energy. H is the enthalpy of the given molecule reaction, and T is the temperature. S is the entropy. So by applying delta G, the entropy of the activity, and delta H, the entropy of the activation can be calculated. So delta H and delta S. So they are given different cases here. Case 1 and case 2. Application for reaction of solution for unimolecular reaction. ಒಂದು single molecule reaction, ಇನ್ನೊಂದು in the gaseous reaction. ಈ experimental ಅಂದ್ರೆ energy of activation experimental, that is delta H star minus P delta V plus RT. So that is the equation 12 for unimolecular reaction and reaction in the solution delta V star. So we are going to apply want of Arrhenius equation. So what does the want of law says here? It is the effect of change in temperature on the system in the equilibrium in the direction of the temperature change. So as the increase in temperature, there will be increase in the rate of endothermic reaction. So endothermic reaction as the temperature increases, the rate of reaction also increases. Here the rate constant with energy of activation for reaction in solution and unimolecular reaction. That is the equation 14. And in the case 2, for gaseous state anta ide, gaseous reaction anta. So the molecules will be in the gaseous form, hydrogen iodine, hydrogen iodide formation aguttalla ಅದು that icon. So here they are given the concentration of the reactants, 1 mole of each reactant or each molecules. So for that you are going to find energy of activation. That is E experimental. And further Arrhenius equation, the relation between the rate of reaction and temperature for many physical and chemical reaction. There can be the equation 16. And E is experimental energy of activation. So A is equal to the collision frequency, but in activated complex theory it has different meaning expressed in the terms of entropy of activation or reaction. So this is until equation 17 of ನೋಡ್ಕೊಂಡ್ರೆ ಸಾಕಿದು. ಇವಾಗ two different cases ಅಂತ ಹೇಳಿದ್ದಾರೆ. And further next is with respect to plot. Here with respect to rate constant and temperature. As the temperature increase, the rate of reaction is decreased here. ಅಲ್ಲ? So as the temperature 1 by T increases, the rate of reaction decreases. So the T is expressed in the Kelvin, means temperature ಅಲ್ಲ, temperature it is expressed in the Kelvin. So log K1 minus EA by 2.303 into 1 by T1. So this is for the rate constant. By calculating, substituting 120A in 20B, by substituting this equation we get the log K2 minus log K1. So this equation is subtracted, we get the equation log K2 by K1 is equal to EA by 2.303 into R T2 minus T1 by T2 into T1. That is the equation 20C. Mainly, it is used to calculate the rate constant of a reaction at different temperature. So T1 and T2, different temperature, we are going to study the rate reaction. So on this, you should memorize this formula K2 by K1. In this formula, will be some of the problems will be on this formula. So So enthalpy of activation ಗೆ you should remember delta H as is equal to EA minus RT, and entropy of activation delta S is equal to delta H by T, and free energy delta G is equal to delta H minus T delta S. So here are some worked problems. Mainly what we need to calculate andre the rate constant of first order reaction. It is at temperature 290. What is the rate constant at 350 K? So 290 temperature ಅಲ್ಲಿ ಇಷ್ಟಿದೆ ಫಸ್ಟ್ ಆರ್ಡರ್ ಅಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ರೇಟ್. ಸೊ at 350 temperature, what is the reaction constant or rate of reaction? So what is given? K1 ಇದೆ ಗೊತ್ತಿದೆ. You need to identify the calculate the K2. K1 ಗೊತ್ತಿದೆ, T1 ಗೊತ್ತಿದೆ, T2 ಗೊತ್ತಿದೆ. Energy of activation, that is 50.2 kilomoles, the given. So you need to calculate the K2. K2 identify ಮಾಡಬೇಕಂದ್ರೆ in the previous formula what we have taken, this formula we are going to set, and log K2 will be keeping on left hand side so that you can calculate the values. ಏನೇನು ಫಾರ್ಮುಲಾಗೆ ವ್ಯಾಲ್ಯೂಸ್ ಇನ್ಸರ್ಟ್ ಮಾಡಿದ್ರೆ ಗಿವನ್ ವ್ಯಾಲ್ಯೂಸ್ K2 will be on left hand side, and we'll calculate the rate constant for second reaction at a temperature 350 Kelvin. So same thing, one more they are given. Here you need to identify the energy of activation. K1 K2 ಎರಡು ಕೊಟ್ಟಿದ್ದಾರೆ, rate constant T1 T2 temperature ಕೊಟ್ಟಿದ್ದಾರೆ. You need to identify the energy of activation. Energy of activation ಅಂದ್ರೆ the energy liberated at the highest when the reaction is taking place. So that you need to calculate here. Same thing, EA 2.303 EA iradna, you will take it on left hand side and calculate same formula. So and this is the end of the unit. So this second unit also completed, third unit agide. So the formation of product during the reaction is explained by collision and activated complex theory for unimolecular and bimolecular reaction. So here in the chemical kinetics, just we are going to study with respect to reaction rate by varying the concentration. Also with unimolecular under one molecule ಇದ್ದಾಗ reaction ಹೆಂಗ್ ತಗೊಳುತ್ತೆ, to bimolecular ಇದ್ದಾಗ with concentration of first order and second order. With respect first order ಅಂದ್ರೆ the concentration of one molecule though, and the second order ಅಂದ್ರೆ it mainly depends on the concentration of two reactants. ಅಂದ್ರೆ ಏನ್ ಎರಡು molecule ತಗೊಂಡಿದೀವಿ reactant, it mainly depends on those concentration. So that can be noted as second order reactions. For those we have derived the derivations ಅಷ್ಟೇನೆ. And also the criteria one more is formation of intermediate. Treatment theory ಏನ the formation of intermediate that can be studied. That is the activated complex theory. Activated collision theory energy of activation means the energy liberated while the reaction is taking place ಅನ್ನೋದಕ್ಕೆ energy of activation. So activated complex theory andre the formation of activated complex means the combined to form an intermediate formation ಆಗುತ್ತಲ್ಲ, so that can be denoted as activated complex theory. Activated complex, that is nothing but the formation of intermediate. So this is the end of the unit 3. Any doubts idea?